Okay, welcome to the first ever, in fact, video lecture that I've put together. Hopefully there'll be a series of these that I will release on YouTube throughout the course of this term, just to go over and emphasize some of the important concepts that I will be looking at in the main lectures. So last week we were looking at some further ideas within MATLAB, and we were looking particularly at data structures, so different ways in which MATLAB handles different types of data and different amounts of data. And we talked about the concept of an array, and an array just being an organized structure in which data is stored. And there were some specific types of arrays that we commonly come across within MATLAB. The first is the vector, or the one-dimensional array. So a vector, let's create an arbitrary vector 1, and let's just say it's the list of numbers 1, 2, 3, 4, 5. And if they are sitting in a row like that, we would call this a row vector. We could take the same set of numbers and create vector 2, but this time organize them in a column. And we would refer to this as a column vector. So here we have a row vector. Here we have a column vector, and both of these things are 1D arrays. Okay, so the row vector and the column vector are both 1D arrays. We then looked at the idea of a matrix as being a two-dimensional data structure. So it's an array in 2 dimensions. So let's call this matrix mat for matrix. And let's assume that it has some arbitrary data in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And typically we would refer to this as being a 3 by 4 matrix because it has 3 rows of data and 4 columns of data. So if you recall, the vector is a 1D array. Now we have a 2-dimensional array, or more commonly we would refer to this as a matrix. Now one thing that is really important for both vectors and matrices, and in fact any type of array, is that there is a unique correspondence between the index of an array, or and the value stored at that index. So for example, if we wanted to look at index 3, 3 within this matrix, that would be the 3rd row down, 1, 2, 3, and the 3rd column across, and we would get the number 11. So we go to 1, 2, 3 is the first index, 1, 2, 3 the second index, and we find the number 11. So the typical notation for this would be to write that if we go to index 3, 3, we get the value 11. And that unique correspondence between the index, which is here, and the value, which is here, is very important when you're storing data in arrays. Now I've recreated that matrix, and just want to think of some other ways that we could think about the data that's stored within this matrix. Now we could think of it as being a series of 3 row vectors. Here's the first vector, 1, 2, 3, 4. Here is the second vector, 5, 6, 7, 8, and then the third vector 9, 10, 11, 12. Equally, we could think of this as being a series of 4 column vectors. The first one 1, 5, 9, the second one 2, 6, 10, the third one 3, 7, 11, and the fourth one 4, 8, 12. So we could think of this as being vector 1, vector 2, and vector 3, the row vectors, or equally we could think of this as being so we could think of this as being the series of 4 column vectors v1, v2, v3, v4. And one of the things you'll be doing in your assignment this week is creating 1D arrays or vectors and then combining them together to create matrices. So we also discussed different ways of constructing 1D arrays, and there was just the simplest case where if we wanted to create the vector y, we could just simply type the numbers in using this syntax here, the square bracket 1, 2, 3, 4, 5, for example, and that would just create the row vector 1, 2, 3, 4, 5, or if we wanted to create a column vector, we would have to type this into MATLAB using semicolons to separate the numbers. And that would create the column vector 1, 2, 3, 4, 5. But there are some built-in notation that can be useful. So for example, if we were to use the notation z is equal to 1, colon 2, colon 10, then this would create the vector in MATLAB 1, 3, 5, 7, 9. So it would start at 1 and go up in jumps of 2 until it reached the value 10. So of course it goes 1, 3, 5, 7, 9, and the next jump would take you to 11, so it stops there. We could also, let's create the vector, say A, using the function linspace. So if we were to use this in MATLAB, linspace of 2, 10, 5, that would create a vector of 5 elements, so 5 numbers, equally spaced, linearly spaced between the numbers 2 and 10. So what we would end up with is 2, 4, 6, 8, 10. Of course, the best way to get used to using these new functions and notation or syntax within MATLAB is simply to open up MATLAB and start playing. So I'd encourage you, when you're in your MATLAB sessions this week, to play with some of these ideas to make sure you fully understand what is going on here. And one final function that I want to make you aware of is the transpose function. Quite often it will be useful if you have a column vector to convert it into a row vector, or vice versa. So if we had, for example, vector 1 as the row vector 1, 2, 3, 4, and I was to use the transpose function to get the vector, we'll call it vec2. There are two ways of typing this into MATLAB. We can simply use the explicit transpose function, so you'd write transpose of vec1, or there's a shorter version which does exactly the same thing, where you would type vec1 and then a little apostrophe, and both of those would create for you the column vector 1, 2, 3, 4. And you may well find it useful to use that function in your assignment this week. Again, I'd encourage you just to go in and have a play with this, the transpose function, or using the short version, the apostrophe here. Of course, this will do things in the opposite direction as well, so if we wanted to convert this column vector here into a row vector, we could simply write, to get back to vec1, we could say that vec1 is equal to transpose vec2. Well, I hope that has been useful, just to consolidate some of the ideas from last week. If it has been useful, I will create another one of these in another week or so's time. Okay, thank you.